What is going on, everybody, and welcome to the 34th part of our machine learning tutorial series and the start of a new section, which is clustering and unsupervised machine learning. So up until this point, everything that we've covered has been what's known as supervised machine learning, which means we, the scientists, have told the machine what the classes of the feature sets were. With unsupervised machine learning, the role of the scientist begins to be further removed. So to begin, we're going to be covering clustering, which comes in two major forms. You have flat clustering and hierarchical clustering. With both forms of clustering, the machine is simply given a data set, which is basically the feature sets and just the feature sets, and then the machine itself is going to actually search for groups or clusters. And that's what it actually does. And then each cluster, in theory, is given like an ID or something, which usually is going to be like cluster 0, cluster 1, and so on. So what's the difference between flat and hierarchical clustering? Well, with flat clustering, you're going to tell the machine, as the scientist, you're going to say, hey, I would like you to find 2 clusters or 3 clusters. With hierarchical clustering, the machine figures out the groups and how many groups there ought to be. So the first one that we're actually going to be covering is going to be using the Kmeans algorithm. So with clustering, we're going to be first talking about Kmeans. So this one's actually a really simple algorithm. It's going to be a nice, a nice segue coming from the support vector machine, at least. And it's quite simple, and the only parameter that you're going, as a scientist, going to be imposing is just simply you choose what k is, and k is the number of groups that you want, or the number of clusters that you want. So here I have a nice, beautiful graph, and with some data points. And basically, the difference between, say, flat clustering and hierarchical clustering would be the following. So maybe you say to the machine, okay, I want to do k-means, and we're going to say k is equal to 2. So this will be flat clustering. So when k is equal to 2, the algorithm is going to go through and try to find 2 clusters, and it's probably, I don't know, maybe you're going to find this, and then it's going to say, okay, this is a cluster. Something along those lines. Probably not, actually. It won't actually. This is just a simple toy example, but actually we'll talk about why this probably actually will not occur, especially with k-means. But anyways, for now, for the sake of concept, k equals 2, it finds those 2 groups. Instead, what if we ran a hierarchical clustering algorithm, maybe something like mean shift, which is the other one we're going to talk about? It might say, I found this group, and this group, right? It's going to say, okay, I found 3 clusters actually. So something like that. But for this tutorial, we're going to be talking about k-means, and let's say we've got k equals 3. The way k-means works is the following. Basically, you'll take your entire data set, and you're going to set randomly, basically you're going to choose some centroids, and those are just going to be randomly chosen to start. So centroids are just the centers of your clusters. So to start, I just typically take the first k values in the feature set, whatever those happen to be, but you can also use random or something to actually randomly select, or you could shuffle your data, then take the first 3 and all that. In the end, it really shouldn't matter, but if you're, if you're not optimizing for whatever reason, it might make sense to like try to shuffle the data and then try again. So what you'll do is, like, let's say you took your first 2 feature sets, and let's just, for example, say it was this one and this one. Now what you're going to do is you're going to calculate the distance of each feature set to the centroids. And then you're going to classify each feature set as, let's say, since k is equal to 3. So let's say we chose these 3. Okay. So what you're going to do is you're going to take each feature set from here and calculate the distance. We already know how to do that. We're just going to use norm or Euclidean distance. And you're going to classify each of these new feature sets as whichever centroid they're closest to. So let's just say this is centroid 0, this will be centroid 1, and this will be centroid 2. Okay, and I'm just going to eyeball this just to get an idea. But we're going to say, we'll start with centroid 0. Clearly, let's do this one, this one, this one, obviously centroid that is 0. This one and this one are all closest to 0. For 1, we're going to take this one, and that's probably it. And then for 2, you would say, okay, all of these little feature sets here belong to centroid 2. And again, these centroids could be totally randomly chosen. You just needed to just pick 3, and it could go. You could have picked a totally different 3. It would have been fine. The end result will still be the same. So we'll have classified all of these, and then what you're going to do is you're going to take all of the feature sets or data points or whatever you want to call them. You're going to take all of those, and then take the mean of those. So find the center of all of those. So I'll put the center in orange, and let's say the center is going to be, I don't know, probably there. Hopefully you can see that. There, here, and then probably here. Okay. So these are our new centroids. I'll circle them just to make them even easier to see in the video. So those are your new centroids. And then you repeat the process. You just keep repeating that process until the centroids no longer are moving. And once the centroids are completely done moving, you've got your clusters. And you can already see, obviously I eyeballed this just so hopefully we would only need to take one step. But you should see that we've pretty much already found the clusters, right? We've already clustered them with k equals 3. That would be this is a cluster, this is a cluster, and this is a cluster. So we're actually already done in one step. So the final step is just simply to repeat step 2 and 3 until you're optimized. The way you know you're optimized is by checking how much that centroid moves, if at all. And again, just like we did with the SVM, you'll probably have some sort of tolerance, and then you'll also probably have some sort of max iter for max iterations, just to say, okay, if we haven't found our answer in 500 iterations, or I think scikit-learn uses 300 as the default, if we haven't found the optimization by then, maybe we're not finding it, or we're not going to, or for whatever reason. Okay, so this is actually super simple. It's easy enough to implement. The one downside to Kmeans is when you have Kmeans basically wants to cluster data in relatively equal sized groups. And so that's kind of like one of the major downsides, is just that it's going to have a hard time picking like differently sized groups because of this adherence to distance rather than some other sort of adherence. So a popular data set is something like this. It's referred to as the mouse data set. And looking at it visually, you would probably agree that, you know, you've got a cluster here, here, and then here, right? And that it makes a, you know, like a Mickey Mouse looking thing. Okay, but because of the way Kmeans works, and even some of the other clustering algorithms work, it's going to, you know, it'll find the cluster center as here, here, and here. But when working out the distances, this cluster might actually be this part. This cluster might actually get, you know, this whole area, let's say, and then this cluster gets this area. But as you can see, what should have been basically this for this bigger cluster is not, because of the kind of adherence to Euclidean distance. So that can be kind of hard, and there are some things, and some clustering algorithms use different what are called kernels, which is what we've already covered. But as you'll see, even if you changed the kernel to maybe a Gaussian kernel or something like that, you are still going to have this problem. So this is probably the main issue actually with Kmeans, other than, as is common with most of the algorithms that we're going to cover, scaling. So scaling, again, you have to compare each point to all other points. Luckily though, like the support vector machine, once trained, once you have those centroids, you can classify new points based on those centroids, and you actually don't need to train anymore. And that's kind of the neat thing about clustering, is that you have what's called semi-supervised machine learning, where you start off with a clustering algorithm. You say, okay, I want to find two groups. And once it finds two groups, you can then translate that to supervised machine learning and say, okay, these are the two groups that we have. This is group 0, this is group 1. And then you can actually use like a support vector machine or something like that on the data. Anyway, what we're going to do now is we're going to pop on over to scikit-learn and actually apply this to a really quick example. We're familiar already with scikit-learn and graphing and all that, so I'm going to just stuff it into the end of this video since there's really nothing new, but we want to at least kind of cover an actual example and show it at work. All right, so before we actually get to applying to a real-world example, I want to go ahead and show a very simple example that can actually be visualized so we can see that the K-means algorithm actually works. So with both of the clustering algorithms that we're going to be covering here, it's not so much of a accuracy or visualization capability that either of these algorithms have. They're more so to like for research and finding structure. So for the most part, when you're actually realistically using them, you're not going to actually see that or have any sort of degree of confidence as far as whether or not these algorithms even work. So we're just going to see it visually real quickly so we can have some degree of confidence before we actually use it on an actual data set. So anyways, let's go ahead and import matplotlib.pyplot as PLT from matplotlib. We're going to import style. We're going to style.use ggplot, import numpy as np, and then from sklearn.cluster, we're going to import Kmeans. Now we're going to define some starting x values. That'll be np array, and then we'll have 1, 2, 3, 4, 5, and 6 elements in here. You can do something you want, but you probably should make it 2 obvious groups, just a suggestion, but you don't have to. You can see what happens if you don't. So I did 1, 2, 1.5, 1.8, 5, 8, 8, 8, 1, 0.6, and finally we'll do a 9, 11. Now plt.scatter, and then we're going to scatter x colon comma 0, x colon comma 1. This is just all the 0th elements in the x array. These are all the 1st elements in the x array. We'll say the size is 150 to just make it really big, and line width's 5, so that's also decent. And then we'll show it. So this is just going to show us the data we're working with. sklean. It's the lean version of sklearn. Oh my god. Wow, that's a lot of typos. We're not making it very far. Okay, let's see what happens here. All right, cool. So we made it this far. Good stuff. Let's see, size 150, line widths. Probably because I'm not using a marker, so it's just like these fat. So maybe if I do this, we don't have that weird halo around. There we go. Nice. Okay, so that's our beginning data set. And obviously, if we say k equals 2, we're expecting that this would be a cluster down here, and this will be a cluster up here. Okay, I think everybody agrees. So now I'm just going to comment these two out. I'm going to try as hard as I can anyway to do that. And then we're just going to define our classifier, CLF, equals capital Kmeans. We're going to say n clusters. That's one of the parameters. That's probably the only main parameter you're ever going to need to use, besides maybe max iteration. N clusters equals 2. I believe the default is 8. Why 8, you ask? I really don't know. I do not know why 8 is the default. Anyway, number of clusters, 2. And I don't even know what would happen if we used 8, because we don't even have 8 data points. But if you used like 6, it would find all those clusters. I really do wonder what would happen. Maybe it would like have 2 centroids on the same. I don't know. If I think about it, maybe we'll do that at the very end. CLF.fit, it'll be for fun, y'all. CLF.fit x, and then basically you fit, and then we're going to access some of these attributes. So we're going to say the centroids equals CLF.cluster underscore centers. And then we're going to say the labels equals CLF.labels. So labels will just be an array purely of the labels of our features. And they will have the same index as our features. So you can think of x as x, labels is your lowercase y, okay, to compare it to previous tutorials. Now, we're going to have a colors list. You can make this a pretty long list if you wanted. I'm just going to go ahead and put 2 things in here because I know we're using K. Actually, shoot, we need probably more next. We're going to... Well, we'll do this for now. So green period, red period, and let's go ahead and add a few here. Red, we'll do cyan period, B period, K period. So that at least gives us, let's try to have, let's see if I can think of one more. I think orange, O, so O period. So these are just like the color. You can kind of get away with this when you do like a color and then a period is like the marker. So it'll be like a dot, hopefully. Okay, so now what we're going to do is we're going to say for I in range of the len of x, capital X though, before we get ourselves in trouble there. For I, so this will just, the I will be our index value, right? So we're going to plt.plot, we're going to plot x, capital, I, 0, and then we're going to plot x, I, 1. Okay, so that's the data. And then we want to have the color. We're just going to say color, and we can actually get away with this. We can say colors. We can just have it passed. So we can say colors, and that's going to be labels I. So, yeah, colors, labels I, and then, so this will be literally like the index. So the label is going to be a 0 or a 1 since we have 2 clusters. So we're gonna use that value. This will be a 0 or 1, which references the index of colors. So it'll be a green or a red. Okay, all that's going on there. And then we're gonna say marker size equals 10. 10. And then that's all we need to do there. Then finally we're gonna do plot scatter, and we're gonna do centroids colon comma 0, centroids colon comma 1, not 12, just 1. Then we're going to say the marker here, yeah, we're going to say marker is an X, lowercase. I'm not sure if capital case would work there. Size will be 150. Line widths will be 5. And that's all we need to do there. And then finally we'll do plot show. Okay, much ado about nothing. Hopefully no typos. Sure enough. Okay, so did we marker size 10? Let's do, maybe we will do 100. It's just kind of small. Okay, maybe not 100. Let's do 25. You guys are being outrageous. Okay, so here we go. So there you have, all right, this is one of your centroids. This is one of your other centroids. And then these are just colored by their group. Now, just so that works, hopefully you can just see that that was successful. So now, you can tell it's successful by the way that it is. Now what we're going to do is, let's do, first of all, just 6. Hopefully it would be like every point. We'll see if it throws through an error. It's probably angry about this. I thought we could do orange. Let's see. I don't know if maybe P is purple. Let's try that. You're killing me. Okay, fine. We'll just get rid of that. And then we'll say, we'll make this list 10 times as long. So that'll be like plenty of color choices to choose from. Right. Okay, so 6 clusters. We get, 6 unique, obviously, data points along with centroids that are kind of behind them. Now let's see what happens if we have 8. Oh, yeah. Okay, so this just has like a simple warning that it's like, hey, your number of samples is 6 and you should be greater than or equal to 8. Okay, just curious. Okay, was that exciting or what? All right, so now in the next tutorial, what we're going to do is actually apply clustering to an actual data set where we believe, because like basically, well, what you might find yourself using this with is like, consider that you work for, let's say, Amazon, and Amazon has some data on some users, and Amazon thinks that each, this data set's really representative on whether or not a user is going to be a buyer or a not buyer, okay? And so they give you this data set, and then so you're going to use Kmeans just to see if it separates the users based on that really valuable data that you think defines whether or not a user is a buyer or not. And you're just going to see, is that what Kmeans actually separates them into, okay? And then later on, you'll see with like hierarchical clustering, maybe rather than flat clustering, thinking like, oh, buyers are just buyers and non-buyers, maybe use hierarchical clustering to find out, no, it's a spectrum where you've got people that are, totally not buyers, slightly likely to buy, maybe likely to buy, highly likely to buy, and certain to buy, okay, or something like that. So anyway, so we're actually going to apply this to an actual data set that we think will be descriptive of something, but we want to get some sort of confirmation that it is. So that's what we're going to be talking about in the next tutorial. If you have any questions, comments, concerns, or whatever up to this point, feel free to leave them below. Otherwise, as always, thanks for watching. Thanks for all the support and subscriptions, and until next time.